Suppose you are very good in a particular programming language such as Java. It does not mean that you will give a best solution to a business problem. As a programmer, you can start the coding work. When you are halfway through, you will encounter with problems such as what to put, where to put, and how to put. They have obtained by trial and error. It means all the hard work has already done. We can use it as a problem-solving template to develop software. Let's have a brief look at the history of the design patterns. The Gang of Four. These are the four people who are the pioneers in the design patterns. They have launched the book Design Patterns Elements of Reusable Object-Oriented Software in 1994. This book contains 23 design patterns. Creational pattern. It is all about class instantiation. The basic form of object creation could result in added complexity to the design. Examples of creational design pattern are builder, object pool, and prototype. Structural pattern. It tells about the ways to compose objects to obtain new functionality. Behavioral pattern. In the context of object-oriented programming, it is known as message passing. Examples. First structural design pattern we are going to look at is bridge design pattern. It encapsulates the implementation class inside the interface class. Handle is interface class and body is implementation class. The users see the handle as a real class, but the actual working is done in the implementation class. Real-life example for the bridge is a household switch. Basic operation of a switch is to on or off, but depending on the context it is operated, the implementation varies. Next structural design pattern we are going to look at is proxy design pattern. Proxy is a placeholder for another object and it controls access to it. There are four common types of proxies. First type of the proxy is a virtual proxy. It is a placeholder too expensive to create objects. Second type of the proxy is a remote proxy. It is a placeholder for the local representative for the object in a different address space. Next proxy is master proxy. It controls access to the sensible master object. The last type of proxy is a smart proxy. It possesses additional features when the original object is accessed. Real-life example is a check. Check is a proxy for the funds in the account. Check can be used in the place of the cash to purchase the items. Ultimately, it controls access to the funds in the account. I am going to first talk about facade design pattern. It is one of the structural design patterns used with object-oriented programming. Facade is basically an object that provides a unified interface to a large body of code, for example, class library. So, a facade can make a software library easier to use, understand and test since it has convenient methods for common tasks, and make the library more readable and reduce the dependencies of outside code and inner working library, because most codes use facade, thus allowing more flexibility in developing the system. The second thing is it wraps a poorly designed collection of API with a single well-designed API. If we consider the real-world example of facade design pattern, consumer encounters facade design pattern when ordering from a catalog. The consumer calls one number and speaks with customer service representative. Here the customer service representative acts as a facade and providing an interface to the order fulfillment department, the billing department and the shipping department. The second design pattern is decorator design pattern. It allows behavior to be added an individual object either statically or dynamically without affecting the behavior of other objects from the same class. So the main intention of this design pattern is attach additional responsibilities to an object dynamically. So it provides a flexible alternative to subclassing for extending functionality. In the case of inheritance, it is not feasible because it is static and applies to the entire class. Next, we move to the real-world example of decorator design patterns. A paint can be hung on a wall with or without frame, but frames are often added. In the picture, the frame is hung separately as well as painting also. The painting may be matted and framed and it looks like a single visual component. That's how decorator design patterns work. Now I am going to talk about adapter design pattern. There are situations where existing component of a system does not fit into current requirements or the user wants it to be done in a new or different way. So, reusing the old to adapt the changes required is better than designing something new. Adapter is about creating an intermediary abstraction that translates or maps the old component to a new system. It allows two incompatible interfaces to work together. Clients call methods on the adapter object, which redirects them into calls to the legacy component. This strategy can be implemented either with inheritance or with aggregation. Adapter function as a wrapper or modifier of an existing class, and it provides a different or translated view of that class. Let's understand it with an example. The old component contains a doThat method and client wants to call doThis method. So the adapter or wrapper class contains a doThis method inside which there will be a call to doThat method of the old component. Therefore, the adapter object instance will have an instance of the old component object. Next pattern I am going to talk about is private class data design pattern. This is not the one of 23 design patterns discovered by the Gang of Four, but some sources consider it as a structural design pattern which seems to be acceptable. A class may expose its attributes for manipulation when manipulation is no longer desirable. Example, after construction. A class may have one-time mutable attributes that cannot be declared final. This private class data design pattern allows one-time setting of those class attributes and prevents such undesirable manipulation. So, here we can protect the class state by minimizing the visibility of its attributes. This design pattern reduces the number of class attributes by encapsulating them in a single data object. It allows the class designer decide whether to provide or remove right privilege of attributes and whether to expose or hide the attributes. The private class data design pattern solves the problems by extracting a data class for the target class and giving an instance of the extracted data class to the target class instance. Let's see an example to understand it clearly. In this example, rather than having all the attributes in the main class, create a data class which encapsulates all the attributes and provide an instance of that data class to main class object instance. If the designer wants to expose some attributes in that object, he or she can provide get methods for each attribute, and if the designer wants to provide write privileges to some attributes, he or she can provide set methods to each attribute. Okay friends, let's see about the composite pattern. The intent of this pattern is to compose objects into tree structures to represent part-whole hierarchies. Composite lets clients treat individual objects and compositions of objects uniformly. In this pattern, we divide the objects into two major categories such as leaf and composite. Leaf and composite must have same behavior, but the major difference is a composite can contain more leaves or composites inside it. The last design pattern we are going to talk is flyweight pattern. Sometimes the user may want to create several objects for some narrow purposes. For example, that they become garbage inside the RAM. Other than the memory inefficient, there is another problem that is time inefficient. Event pattern is used with factory design pattern, which allows the programmers to create objects in an efficient manner. In this UML class diagram, the client must ask the item factory to produce an item by providing necessary information which are necessary to create an item object. The item factory will contain an instance reference of item inside it, and it will create a new object only if the reference is a null reference. Then it will modify that object using the item setters method and return it to the client.